Hi and good evening. My name is Badru Fitri, and today our group would like to present about our topic, which is fiber optic. The group member consists of Cha Ziyi, Jonathan Ting, Mo Yao, Ling Zhengkai, and myself Badru Fitri. Okay, for the content of this presentation, it consists of introduction of fiber optic, history of fiber optic, type of fiber optic, implementation of fiber optic, and lastly, a comparison of fiber optic with other cables internet access. Okay, let's begin with the first one. Introduction to fiber optics. Okay, fiber optics and light signals are used in transmission lines to send information. Optical fibers are thin and can be made of either glass or plastic. They can send light a long way. Light is kept inside the fiber by total internal reflection. This happens when light goes through a medium with a higher refractive index, like glass or plastic, and then hits a boundary with a lower index, like air. This sends the light back to where it came from, keeping it inside the fiber. Fiber optics send data faster and farther than copper cables, and they don't get messed up by electromagnetic noise or interference. Fiber optics is great for high-speed data transmission, telecommunication, and computer network because of these benefits. Fiber optic have many advantages over copper cables, and their use has helped change the way data is sent. Fiber optics, for example, can send data as much faster and over much longer distances than copper cables. This is because fiber optics lose less signal over distance than copper cables. This means that signals can be sent over longer distances without the need for signal boosters.
Hi, I'm Ling Kai. So I will present the history of fiber optic. In the 1953, the scientists Netherlands companies carried out one of the earlier fiber optic experiments. Companies was able to demonstrate the light could be transmitted through a bundles of here and his glass fibers. He also often refers as the fathers of the fiber optic. So the fiber optic is start from here. We can say it start from here. Physically have a result. Okay. So in the 1961, Elizabeth Stevens published a theoretical description of single-mode fiber core would be small that it could carry a light with only one waveguide mode. So the single-mode fiber core is published in here. Okay. After that, in the 1964, Standard Communication Laboratory in England proved that line loss of existing glass fiber could be diminished by removing the impurity. They also point out the right material to use such fiber is silica glass with high purity. So in here they are pointing out the materials. Okay. in the 1965, the German physicists demonstrate that the first functional fiber optic data transmission system. So start from here, they already demonstrate the transmission system. Okay, in the 1970, Corning glass work make single mode fiber and with anten- attenuations less than 20 dB per km. In the 1977, AT&T successfully transmit telephone conversations over the fiber optic and demonstrate the feasibility of using fiber optic in telecommunications. So start from here, they already trying to using the fiber optic in the transmissions like in the telephones. Okay, so in the late of 70 and earlier of the 1980, the phone companies start to use the fiber optic to rebuild their communications infrastructures. Okay, so they already start to use it. Okay, in the 1986, the Emmanuel Desavers invented the airborne drop amplifier, which reduced the cost of the long distance fiber system. In the 1990, so the fiber optic has largely replaced copper wire as the main methods of sending data across a long distance. So until today, the fiber optics are often used to transmit the voice data, video signal around the world. Uh, it's also forming the backbone of the internet, enable high-speed data transmission and others advanced communications service. This technology is also used in various applications like medical equipment, military communication, and industrial process. So now I will talk about the type of fiber optic. So there are main two type of fiber optic used in which is the single mode fibers and multi mode fiber. So you can see the picture here. So this is the multi mode fiber. This is a single mode fiber. In the single mode fiber, it has a small core diameter, typically around 9 micrometer, and designed to propagate a single light through a core. With this narrow beam of the line and low annotations, single mode optical fiber is well suited for long distance telecommunication and high speed data transmission. So single mode optical fiber can transmit the signal up to 10 km without any loss of signal. Okay, so it's ideal for long distance transmission, and we are now primarily to use it as the wide areas network, which is one connections. Okay, so for the multi-mode fibers, it has a large core diameter, typically around 50 to 100 micrometer, and it support multiple simultaneous line. Okay, this type of multi-mode optic fiber it result in a wide beam of light, high annotations and distortions, and this kind of characteristic will cause it to have a short distance transmissions. Multiple mode fiber is commonly used for the long or short distance applications such as the local area network LAN connections. So this is my presentation, and I will pass the presentations to my group mate. Okay, thank you.
Good day to all. I am Jonathan Ding, and I will be talking about the implementation of fiber optic. So here there will be six stages, and it is the basic stages of implementing the fiber optic in an area. So first, it will be the planning. So the location of the fiber optic network, the amount of fiber optics that are needed and the equipments that are required are decided. For example, where the fiber optic should be laid so that every users can have the fiber optic connections. Next will be the installation. So it is the physically laying of the fiber optic cable and installing the necessary equipment. These are normally done by our internet service providers such as the Telecom Malaysia and the Time.com. Next will be the testing stages where the technician will verify the quality of the signal and the performance to the of the performance of the network to ensure we have stable connections throughout the day. Next will be the termination. It is the connecting the fiber optic cable to the equipment such as the optical transmitters and receivers. Next will be the maintenance. For the maintenance part, it is actually the regularly checking of the network and performing any necessary repairs or upgrades to keep the network functioning. Lastly will be the optimization. It is to make any necessary adjustment to the network to improve performance and ensure reliable and efficient transmission of data. Next, I will be talking about continue about implementation of fiber optic. There will be three types of network on how the fiber optic cables are connected and how they communicate with each others. So what is a core network? The core network is the backbone of the fiber optic communication system. It is responsible for transmitting high bandwidth data over long distances between cities, regions, and countries. It is typically consists of high-speed optical switches and routers that are connected by optical fibers, and it enables fast and reliable communication between large data centers and other network nodes. Next will be the broadband network. It, the broadband network refers to the intermediate layer of the fiber optic communication system which connects the core network to the access network. I will be talking about the access network in the next slide. So the broadband network is responsible for providing high-speed internet access to homes and businesses in a particular region. So core network is to provide the connection between cities or even countries where broadband is provide internet access to the particular regions. It typically consists of optical line terminus or LTS and optical network units or NUS that are connected by optical fibers, and it provides fast and reliable broadband services such as the internet access, voice, and video services to the end users. Next will be the access network. The access network refers to the final segment of the fiber optic communication system, which is these two. So firstly, it will be the core network, next the broadband network, and lastly the access network. So uh, the final segment of the fiber optic communication system that connects the broadband network to the end user's premises, that is the homes and offices. This network typically consists of fiber optic cables and other passive components that are installed directly at the end user's premises. It provides high speed and reliable fiber optic connections to homes and businesses. The access network enables the end users to access the internet and other digital services at high speed with low latencies. That is all from me. Thank you.
So now I will directly go to my part of presentation. So in this table, we can see the comparison of fiber optic with other cables. So in this case, I have choose the two other cables which is twisted pair cable, cord cell cable, and the main is the optical fiber cable. So with the table shown, so we can conclude that actually the fiber optic cable is the most difficult to install and implement, but it has the highest speed and the most of the benefits that the other cables doesn't have. Besides that, it is also considered the most expensive one among the cables. So let's see one by one with the comparison. So the external magnetic field. So the twisted pair cable will affect due to the external magnetic field, and causal table will also be affected. So we can see that the fiber optic cable, it does not affected by the magnetic field, and it do not even have the power loss due to absorption, scattering, and bending. And it has the smallest diameter among the cables and very high bandwidth. So with this being said, we have even more benefits compared with other cables. So electromagnetic interference. So the fiber optic will not be affected. So the the twisted pair cable will mostly be affected, while the coaxial cable can be prevented from being affected by adding the shielding on the cables. So for the attenuation, so the first cable has the highest, then the Corsair have the low, and the fiber optic has the lowest. So other than that, the data rate is very high for the fiber optic comparing to others, and it has the noise immunity or by using the fiber optic cable. So since the this has so much advantage, so this is the only few of the disadvantage, which is the cost is very expensive. So for the security, it is guarantee of the transmitted signal, and the power loss. The power loss has reason conduction. So fiber to the X, which is FTTX. FTTX is all kind of fiber infrastructure that provide local loop used for last mile telecommunication. So we have actually many types of FTTX, which I have given three types of it, such as the fiber to the home FTTH, fiber to the node FTTN, then the fiber to the building FTTB. So we can see here FTTH. FTTH is the most widely used variation of the fiber optic access infrastructure. FTTH is used to reach the boundary of a home of premises. So why it is very widely used is because FTTH is suitable for home users which need different types of connectivity, such as TV, video, and music. Currently, in Malaysia, the most of the urban places has the coverage of FTTH. FTTH is implemented using the end-to-end passive optical network (PON), which has two key network components known as the optical line terminal (OLT) and optical network terminal (ONT). So the last is the FTTH is better than cable broadband and FTTN. So FTTH provide the highest bandwidth as we have said before. So FTTH provides multi gigabits of download speed and upload speed more than 1 gigabits according to the Federal Communication Commission. So if we compare to the broadband, it only provides a minimum of 25 Mbps of download speed and 3 Mbps of upload speed. So if we compare it to the FTTN, so FTTH is better than FTTN at it use the end-to-end fiber optic connection. This means that the transmission data is not limited by FTTN as it uses the copper wireline infrastructure. That's all for me, and I will pass to my team members.